reoccurring theme. What do you notice about the numeric value of the KSP?
Pretty small.
Pretty small. Favored forward, favored in the reverse. Reverse. Is calcium hydroxide going to be soluble in water?
Slightly.
Yes. No! It's not! That's why it's not favored in the forward direction.
Wait, so
calcium hydroxide?
Calcium hydroxide.
I thought all hydroxide was
A little bit.
So what do we write?
Not with calcium.
Or magnesium. You did a lab with magnesium hydroxide. You made a precipitate of magnesium hydroxide.
Oh wait, isn't it all group 2? I feel like that.
Yeah. So, don't confuse strong acids with solubility.
calcium isn't.
Okay. So let's start with this. What do you have for 4A?
C. Calcium hydroxide goes to calcium ions.
Can you stop tapping, please?
Beautiful.
Thank you.
Hey, that's what I
Great job, team.
I did that
too.
Let's make sure we all
I
sit
did
next to
plus
each
H
other.
too.
We are not
No, I
getting
can
this
sit
for
in
you.
the top right of that room.
Okay, then I'll
Here, start that back up.
Sit next to me.
It is.
Okay.
Wait, okay,
Like
Bernier,
it was
this is a
young.
genuine question.
It's
You know,
Final, right?
when water is a part of the
It can't reach.
Because if
I
your
have cells,
calcium
bro.
hydroxide reacts with water,
Your finger looks
so
like a
does
thumb.
it.
So it'll say it
Maybe
reacts
like a
to
rational
use
one.
meaning
Was it
it's
Gavin?
Okay, that makes sense because I was like, I have no idea what to
Like
That
if they-
is
if they
foul.
write the dissolution of sodium
Look at
chloride, you would just put NaCl turning
I know
into
you're
sodium
right, so
ions
no.
Okay.
and
I
chloride.
don't want to talk about it.
That
Let's just go
makes
get a
Is the
manicure.
water there? Yes. Is it part of the reaction? No.
I bite my
Alright.
nails.
Okay.
There's no point.
Now,
Okay, let's do it.
when you get to B, calculate the molar solubility of calcium hydroxide and put 1 molar calcium nitrate. So this is where you do want to use a rice chart.
Yeah, I kind of got lost on that one.
So is calcium nitrate soluble in water?
Oh yeah, all nitrates are
Oh,
solid.
nitrates are soluble.
soluble.
So what that means is that you're going to have a 0.1 molar solution already of calcium. Okay? That's what you got.
Oh, it's like a buffer.
Oh, it's like a buffer because you're already starting with a high concentration of the calcium ion. So what are you going to let the initial concentration of the hydroxide be?
X.
No,
Zero.
0.
Because there's
Okay?
Oh, I thought you were talking about the calcium hydroxide.
No. So how much are you going to add to the calcium?
That's what we.
Is this one X? There's the X. Gotcha.
But how much are you going to add to the hydroxide?
2X.
2x.
Gotcha.
Because for every 1 calcium, you
Two
generate 2 hydroxide. Okay? Cool with that. If it hadn't said, if they hadn't given you the concentration of the calcium, you would have just gone X and 2X. Okay? But they didn't. They said, oh, okay, right, we're already going to overload this with a bunch of calcium. So, is the addition of X going to make any difference? No. That's just going to be 0.10. What's going to be the concentration at equilibrium for your hydroxide?
2X.
Now, your KSP, which they gave you, is going to equal what? What are you going to multiply together?
Product over reactant.
But the calcium hydroxide is a solid,
Yeah.
so there is no concentration of calcium
So it's
hydroxide.
calcium concentration hydroxide.
Yeah, so you're going to multiply it by the calcium concentration times the hydroxide ion concentration. But Will Stanley, what's going to happen to the concentration of the hydroxide ion solution?
Squared.
It's going to get squared. Right? So,
Yeah.
oh!
You don't even need to keep going. I got you.
So, actually, I'm going to. So this is 1.6 times 10 to the minus 6 equals 0.1. And then you're going to have 2x, but that's going to get squared.
So it's like 4X squared.
Ah, so it's like 4x squared. So this becomes 4x squared, so you need to solve for x.
You're just like divide by 0.4 and square root. What do you get?
What's that number?
So what'd you get for x?
Wait, I got it. 1.8 to the negative third.
1.8 times 10 to the minus 3. So here's the bigger idea. So that's going to give you, because that's x, it isn't like 2x, okay? So this is where this always gets a little bit wonky with KSP problems. So that had to be generated by the calcium hydroxide dissolving. So it sounds a little bit wonky how they ask the question, but since they're asking for the molar solubility of calcium hydroxide, so once you get X, that is that molar concentration of the calcium hydroxide, okay? Because that would be this 1-to-1 ratio with the calcium.
Why
Okay?
did we not write X?
What do you mean? Where?
Like as the initial.
Like in that first column.
Why is there nothing in the initial?
Because on the initial, you have a chunk of calcium hydroxide. And this thing is going to dissolve until the calcium ions and the hydroxide ion concentration reach a point where mathematically, when you multiply them together, you get that 1.3 times 10 to the negative 6. That's why it's just like, but what happens here is that because of the fact that this is starting off at 0.1 molar, that's why I said it's like a buffered solution.
So we don't really put anything because it's
No, your ice line is 0.1 and 0.
No, I'm talking about for the first one. We don't put anything because it's a solid.
Yes,
So we're not putting anything.
there's nothing, yeah, and are you talking about that column?
Yeah.
Yeah, there's, because it's a solid, there's no concentrations there.
That makes sense.
Yeah,
But then our original concentration for X though?
yeah, so once you get X, once you solve for that, that's how much of this stuff had to dissolve to create the concentration of the other stuff.
Okay.
Okay, cool with that.
Yeah, I drew.
Cool, that was
That
another
was
one.
kind of
Okay, so
Wait,
here's
we have C.
the 2016.
What?
I think you brought C.
talking about a scratch record. It's too
Oh.
far.
I do have a question.